My talk is going to be based on the Venus section of Worlds in Collision. It's not really the words of Dr. Velikovsky, but the survivors that he quotes, and the description of the events that took place. The dates are not important. I'm comfortable with his dates, but it doesn't really matter. It could be Nibiru, it could be Saturn, Jupiter, Mars, but I'm comfortable with Venus as he thought. Let me get a different image there. The picture that's painted is dust, sand, gravel, rocks, very large boulders falling from the sky, mingled with a river of fire. Dr. Velikovsky thought that was oil. In many cases it might be, but it might also be plasma, similar to the aurora. The dust, sand, rocks, and gravel and boulders were mingled with a river of fire. According to the Mesoamericans, the rocks were glowing red hot. If you can heat a rock to incandescence, it would be much easier to heat dust. So you have molten material. The electromagnetism might pull in iron preferentially. It's raining oil for days and nights. The oil's running through rivers. People climb trees to escape it and drowned. According to the Mexicans, I think it killed more people than the rocks and everything else combined. There's a hurricane going on, beyond our description, worse than Andrew, which almost killed me. It might have, actually. The sun rises where it used to set. That's a tough one. And it could be a tippy top, but from what I see in the field, it really looks like it stopped rotating and went the other way. You can go to the headwaters of the Colorado River. Rocky Mountain National Park, Fraser, Colorado. I've spent quite a bit of time there. You can see the valleys are full of sediment to a large height, flat on both sides, equal height, as if water was pushed up from the equator. There's a 13.25-mile bulge of water at the equator because of centrifugal force. If the Earth ceases to rotate, according to Dr. Velikovsky, the water would rush north and south. The dust that's falling would be part of the flood. That is what I believe is the sediments up at the top of the Colorado drainage. So it's really a mess, and it's electrical. An interesting image from Wiki Images, Wiki Maps. The yellow is sediment. I believe that's part of the flood. It was basically underwater, being moved around. The part that's not yellow, this area here, this circle right there, are mountains in a circular pattern. Within that circular pattern, which I think is a vortex, there are more vortices right here and right there. We'll get into those a little later. But what's kind of interesting, we were looking at Valles Marineris earlier, wall, seeing the shape of a galaxy. I see mountains coming up through Canada, curving to the left. They actually go through Alaska into Far East Russia, and then an arc of volcanic islands come down. Coming out of the south of this, you have mountains curving to the right. Oh, the Canadian Rockies are a little blip there. You got Baja here, kind of similar to the Canadian Rockies on the right-hand side of this. These mountains come down through Mexico, Central America, actually go through Colombia, Venezuela, with an arc of volcanic islands coming back into Mexico. It seems to look a little like a galaxy or a huge low-pressure area, like a giant hurricane. That shows the mountains going through, coming around, and back. Again, down, around, and back. Could be a coincidence, but in an electric universe, I picture Venus sitting over here as it bobs up and down, as Dr. Velikovsky thought. It would come in close, there'd be a discharge, it would release it, and it came back down during the plagues of Egypt, during Exodus. That's how he describes things. These are volcanic formations. They swing around here, they go up, come around, down. A lot of these volcanic formations have something in common. Missing volcanoes. The volcanoes have gone away. They've disappeared completely. The geologists are befuddled. They go out and look for them. They can't find them. They know they have to be there because there's basalt. What else could possibly heat dirt other than a volcano? Except in an electric universe with a river of fire, we now have another option for molten rock, heavy with iron, electromagnetically possibly pulling in iron from a dusty atmosphere. As a friend of mine points out, it's dusty plasma. So it's going to be affected by an electromagnetic event hovering over here, 10 to the 39th power, or a lot more than gravity. It could be pulling in dust as we interact with Comet Venus from thousands of miles, shaping it with a hurricane force wind and accumulating it in mountains. These are plutonics. This is granite and its cousins. It's interesting in that on the left side of this, there's a lot of granite. On the right side of this, there's a lot of granite. It seems like a mirror image. Also, this is kind of interesting. This is the Sierras. Is a 400-mile-long pluton of solid granite, the largest pluton on the planet. Under the pluton of granite is sediment. The granite supposedly bubbled up from below. So how does sediment get in between that? There should be a tongue of granite going down to wherever the granite came from. So geologists have the Pacific plate shoving sediment underneath of the granite because they have to explain it. But if the granite came from the air, it would be sitting on top of the sediment that was there to start with. Now we come over to metamorphics. The Sierras have metamorphic rock, but not enough to show up on here dramatically. But the coastal range does, and you can see there's sort of a circle there. And then we have the Canadian Shield with Hudson's Bay in the middle. This is all flat, and it's all metamorphic. This might have something to do with that. Could be a positive, negative, negative, positive, I'm not sure. I'd like to have the EU folks sit around and drink and talk about this in the evening while I can listen. But it seems as if something happened over here. And I'll show later on that it seems to have been rapid and it seems to have been one event for all the mountains. And I don't want it to be that way. I'd like it to be simple and embraceable. But it's not. It looks like it was really a horrible thing with very few survivors. And in Worlds in Collision, the survivors thought they were the only ones. They come out of their cave. They were the only ones that made it. They don't know anybody else in the neighborhood for 100 miles. There's no communication. That's a recurring theme, a lot. It happens in Mexico. It happens a lot. This is on Highway 93 north of Las Vegas. This is Welded tuff. It's a wonderful formation. Welded tuff is red-hot dust that comes out of a volcano and blows downwind. It's so hot that it sticks to the windward side of obstructions, and grows back and up into the wind. This is an accepted geologic process. The problem is many times this is 40, 60 miles from a missing volcano. And if you look at a volcano at night when the dust comes out, it's incandescent. It blows downwind a very small distance and it's no longer incandescent. So 40 miles downwind, it's not going to make rock, it's going to make dirt. You need something to keep it hot, like a river of fire. This is a close-up photograph of them. It's 30, 40 feet thick on the top, solid rock, not like partial rock. This is gnarly rock. This is the edge of the formation. We have windward over here and leeward over here. The wind is blowing from here this way. It gets to this ridge and it goes beyond. At first I thought these were dunes everywhere. But dunes only happen with dry sand. This isn't dry. This is either wet dirt, clay, mud, sticking, or it's incandescent, sticking to windward. And it can't accumulate on leeward because it blows past it. So you get layer after layer building up, and you can see how these layers accumulated. This is not wild speculation. This is a geologic process that's accepted universally, the welded tuff process. When my friends and I discovered this, it was really convenient. It made everything so much more simple than it had been in the past. You don't need a lot of post-process activity to do this. It happens on its own. And it makes a dendritic ridge along the side. That's Mars. That's this process. They kind of look like cousins. So it's hard, you can't say that electricity can't make dendritic ridges. It probably can, but there's a lot of other processes that seem to produce dendritic ridges. Mount St. Helens, after the landslide and pyroclastic flow, there were explosions in the valley where this material accumulated. After the explosion, the sides of the formation that was created by the explosion started to slough. It created dendritic ridges. There are dunes in San Francisco after a storm. As there were landslides, it created dendritic ridges. There's a number of ways to make dendritic ridges. And this seems to be one. Right along here, you can see back here, there's another one back there. This is the area. The wind's coming this way. And these welded tuff formations go all the way across Nevada, hundreds and hundreds of miles of mountains made of welded tuff. I think they're external. I don't think they folded up. I've been looking for folded mountains. They might exist, and I'd be happy to find one. Dr. Velikovsky thought mountains were folded because of the stress of this ceasing of rotation. His advisors gave him the standard geologic model. I hate to disagree with them, but it seems like there's other options. So this is an area west of there. These mountains seem rather circular, and the circularity of them goes back to that point. There's circular mountains over here, right at the base of the Sierra. This one here in particular. These are welded tuff, but on top of a lot of these mountains is Dolomite. And Dolomite's a big problem for geologists. If you Google Dolomite problem, you'll get page after page of links. It doesn't form at the bottom of oceans the way geologists want it to. They need it to, but it doesn't do it, according to chemists. They've tried to make Dolomite precipitate out of ocean water. They can do it, but they have to boil it and fill the water with uric acid. So, picture dinosaurs urinating in a boiling ocean. 600 million years ago. And then that Dolomite that can't happen is thrust up on top of mountains, like the Dolomites in Italy. The top of the mountains have the Dolomite. It's almost like I wrote the reports about the Dolomite myself. The beauty of Dolomite is when they went to Comet Halley, they found 7% Dolomite, according to NASA. And they claim it's understated because it's tiny little crystals, microscopic, and their spectrometers miss a lot of it. So there's probably more. So you have comet dust that can answer the Dolomite problem. All over the world, you have this Dolomite. It's my best friend. It's just the most wonderful stuff. So this whole thing seems to be a vortex. As part of that larger vortex that we saw earlier, this would be the western part of it. That shows you where the center is. That shows you the mountains. There's a Dolomite mine right there. I'm friends with the general manager. I think he might give us a tour on our tour. It's the largest one in California. But the Dolomite seems to be circular. This is Four Corners. We're down here. This red thing here are granitic and metamorphic mountains that seem to be in a circular pattern. This goes over to Highway 93 right there. So this seems to be the eastern vortex with a vortex to the west, and that's where they come together. And if you have two vortices, you might actually have a double layer in between explaining all that melted stuff. And there's other things going on up here, which I'll get to a little bit later. Actually, they're right there. Could be a coincidence, all this, but I really don't think so. This is the welded tuff. This is actually Dolomite down here trending this way. The welded tuff, we're on the leeward side. The welded tuff trends back in the other directions. These seem to have been fairly simultaneous. I would think that these were first, and then this covered the area going behind. So it gives you a feel for the layers of dolomite, layers of shale. The dolomite comes in layers, and it's up to 6,500 feet thick. And then on top of one formation, like the Bonanza King, which can be up to 6,500 feet thick, there's more dolomite and limestone underneath of this. Limestone comes from comet dust too, from Comet Halley. I'll get into the oil from Comet Halley a little bit later if I have time. There's cubic kilometers of it on this little tiny comet. This is welded tuff south of Pahrump. It gives you some idea. It seems like the current density goes up and down. I picture Birkeland currents spinning. One positive filament, one negative filament. They're attracting different things ionically. So they're pulling dust in, making layers. Dolomite shale, different types of welded tuff layers. Everything has an ionic nature. It's going to be attracted ionically, but as it spins, you get different types of material. These are mountains. I spent time here recently. This is dolomite, and it's alternating layers, and it makes dendritic ridges on the leeward side. It's just a natural part of the process. You don't have to add anything. It comes out this way. I've done experiments with spackled wall stuff, and it builds back up in the direction that you're spraying it from, kind of similar to this. And it makes a cliff on the leeward side. This is looking from the side so that you can see the layers go through. They're not just a surface feature. One layer, another layer, all the way through. Dolomite shale, dolomite shale, dolomite shale. I'll get into the oil right now. Almost all the oil that we've recovered up until very recently has come from dolomite because it's porous. We couldn't get at the shale oil. Dolomite being porous, you put a hole in the earth, open pipe, the pressure pushes it in, and because it's porous, it can keep pushing. With shale, it's a solid rock. You have to frack to get it out. Comet Halley has the equivalent of cubic kilometers of oil, almost identical to the oil in oil shale. That's really convenient from a little tiny comet, 12 by 8 miles. So think about Venus being 8,000 miles across. Scary comet, eats people. We saw Dave's pictures of all that. It gives you the opportunity to explain the dolomite and the oil. They come together. They're a package. They're part of comet dust according to NASA. If you search shale oil, the last paragraph on Wiki, it talks about extraterrestrial oil and Comet Halley and the cubic kilometers. Each cubic kilometer is 8 billion barrels. Think of the potential for Venus, and think of worlds in collision and eyewitnesses emotionally describing rains of oil for days and nights, and it runs down rivers into lakes. Just north of here, not too far, is the Green River Basin, north of I-70 in Utah. There are 3 basins associated with this, 3 lakes. Has 4 trillion barrels of proven reserve, more than half of the oil in the world. Proven reserve. There's oil wells everywhere. It's not theoretical. I think that yellow map shows what caused it. It's where the oil came from. It comes from comets, not dinosaurs. And it doesn't, the abiotic oil people have it coming from volcanoes under the ground, and it gets really complicated. If you listen to our ancestors, it came from above. It's comet oil, in my humble opinion. This is Oregon, Smith Rocks. This is welded tuff. That's Windward. That's Leeward. These are the dendritic ridges. The missing volcanoes over here, it went away. I want to do a charity for missing volcanoes. This is a map showing it. You can see that it makes pinnacles. That's the process. These are individual. They start to grow together over here. That's my photograph. It makes triangles. This is the flat leeward side. When the current density is high, it seems like this process is exacerbated. And it grows back. The wind's coming towards us. This can't grow because the wind is coming around here and the dust is blowing past it. It blows into water, it gets washed away. Even if it's red hot, it's now dirt, it gets washed away. This is the water line. There's actually a creek that comes by here. It must have been flooded during this flooding stage. But these shapes are really important. We're going to see Mount Whitney shortly, which is granite. It has the same shape and a completely different explanation from the geologists. I'll get into some funny stories about that later. This is Mount Whitney. This would be Windward. This is leeward. Here's the cliff. Here's what I like to call the water ski ramp. It's nice and flat. It's building back and up into the wind. It's hard to see the layers with granite because it's so molten. The layers seem to have blended together. This is looking at it from above. It's hard to see a little bit. Here's the ridge line right there. This goes down to the Kern River. Goes down, empties out, down by Bakersfield. And then these mountains start again with a ridge and a windward. This is leeward again and windward. It's like the wind was coming from the west, making these mountains of granite. This one shows it more clearly. Windward, leeward. Same thing there. There's Mount Whitney. Reminds me of Welded tuff. And if this is bubbling up from below, it shouldn't look anything at all like Welded tuff. It has a completely different explanation. They seem to be cousins. This is Maroon Bells south of Aspen. This is conglomerate. People try to climb it and they die. Their anchors fall. And then the rangers have to carry them out. They gave me all these descriptions of how difficult it is to carry dead weight out of the mountains. It's not consolidated. This is leeward. This is the other side of the valley. This is windward. The next mountain is the same. They repeat themselves. The wind is from the same direction. Although these are not straight line winds, in many cases they're vortices. And the trending is different from one side to the other, which is difficult for plate tectonics to explain. They don't have just one plate bumping into another. They have to have a disappeared plate. Really? Really. Oh, wow. All right. This is Frenchman Mountain, just east of Las Vegas. You can see the layers. They all go back. These are the same layers as the Grand Canyon. Right here at a 50-degree angle. That's one extra layer. This is leeward. It's building back. The wind for this is all from the same direction. If the wind was from the south, this would be covered. You wouldn't be able to see it. If the wind was from the west, on this side, it would cover it. All that would disappear. Unfortunately, this looks like it's one event down to the schist, the Vishnu schist, and the granite that's at the bottom, the same as the Grand Canyon. I don't want to make it so dramatic, but unless the wind was from the same direction for multiple events, you wouldn't get this. And that makes it really spectacular. I'd like it to be less spectacular. It would be more embraceable. But it's as if that happened during the plagues of Egypt while that vortex was taking place. There's going to be a discussion later on this evening at 6:30, informal, with a computer where I can use Google Maps on all my images, and we can go through all these things. That's the leeward side of Frenchman Mountain. The Vishnu schist is down there. You can see the layers building back. It makes dendritic ridges. They come stop. 5 minutes, finished. Cool. It's better than I was hoping for. This is the majestic Catalinas, just north of Tucson. This is nice. It's metamorphic. You can see it trends back. This is granite. It's unbelievably thick. This is like a couple thousand feet thick of solid granite. This is the leeward side. On the back, you can see the water ski ramp. It's nice and smooth. The wind was coming towards us. This is Snowden Peak. It's quartzite. It's metamorphosed quartz. There's missing pieces. I think this was electrically removed. You can see the layers if you look at the photograph where it's clear on a computer, building out back towards us. This is the leeward side. They're kind of dendritic, but you can't see those gaps because the energy that created them, I think, was coming from the windward side. It didn't get through. This is the base of it. It's all dendritic on the leeward side. This is Zion Park. When I talked about Snowden Peak when I was writing this, or sort of writing it, there's not a lot of words, I said that I had never seen a canyon that seemed to be excavated electrically, although I was open to it. I'd love to find them. But they don't seem to be produced that way. But these are 3,000-foot canyons that are straight. And it seems as if the electricity went right through it. It goes past the high point, where the dendritic canyons, which I think are fluvial, stop at the high point. They get smaller as they go up. There's less water. They don't go past the ridge. These go past the ridge. This is Snow Canyon over here. This is Kolob Zion. These are all zapped. These are where the two vortices are coming together. And it seems as if something came from the south and ripped these suckers out. This is shale. This is mud. Up at the top of these formations, that's how high it is. These formations have the same mud on the top of them. The current couldn't get to it. But originally, this must have been covered just like that, and then these canyons were removed. It removes the sediments much easier than it removes the welded tuff formations. That's a close-up. Now you can see the slosh here. You can see the depth of the canyons. They go straight. They don't follow the drainages. They don't follow the dendritic paths. There's rivers running through here. They don't go where the path would be easiest. They just rip right through a mountain. So I've been looking for electric canyons, wanting to find them for 6 years. And finally, I missed them because I was looking for dendritics. In reality, the key to this is just like the rills on Mars and the moon, they're straight. And I think it's like a ray gun, probably electrons, just going right through it. Although I'd like to hear Wall and Don and Mel and folks talk about this, again, with a lot of liquor. This is what happens. This one last one. This is at the edge. This isn't in the canyon that's removed. This is where the process is slowing down. This is what the process is like. It scratches the material away and disappears it into dust. This is the marks. These are the marks that you look for. They're in Las Vegas at Red Rock Canyon. You can see how things get affected electrically. This is the electric universe version of geology. So please stop by.